Alright, this is your answer key worked out for your exam review. Please refer to the PDF version to get the nice, neat form along with all of the formulas highlighted. So numbers 1 through 4 are all going to be using SOHCAHTOA. Remember, SOHCAHTOA is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So like on number 1, we're given 40 degrees is here. In reference to 40 degrees, this is the opposite leg and this is the adjacent leg. So I'm going to use tangent on this one. So it'll be the tangent of 40 degrees is the opposite over the adjacent. Since x is in the numerator, we're never going to be multiplying to solve this one. So it'll just be 10 times tangent of 40. So this one I'm going to be typing in my calculator. 10 times the tangent of 40 is 8.4 when rounded to the nearest tenth. Number 2, the angle is here. X is the hypotenuse regardless of where the angle is. Remember, the hypotenuse is always across from the right angle. 14 is the adjacent leg, so adjacent hypotenuse would be cosine. So that's going to be the cosine of 40 is the adjacent over the hypotenuse. This time our unknown is in the denominator, so we know from whenever we did this in class that's going to result in division actually. So 14 divided by the cosine of 40. And I get 18.3 for that one, rounded to the nearest tenth. Number 3, here's my angle. In reference to my angle, this is the opposite leg. And again, 20 is the hypotenuse regardless of where the angle is. So this one's going to be the sine of 32. The opposite is x and the hypotenuse is 20. Again, my unknown's in the numerator, so I'll be multiplying to get my solution here. So 20 times the sine of 32. 20 times the sine of 32 is 10.6 approximately. Number 4, we're looking for an angle. Remember, when we're looking for an angle, the last step's a little different. So in reference to my angle, 15 is the hypotenuse regardless, and 7 is opposite. So this is going to be the sine function. This time I don't know the angle. Opposite over hypotenuse is 7 over 15. Remember, when we're looking for an angle, we're going to use the inverse of sine. So we're going to use that operation in our calculator, the inverse sine of 7 over 15. So the inverse sine of 7 over 15 is what I'm typing in my calculator. Rounded to the nearest tenth of a degree is 27.8 degrees. So those first 4 are our trig problems. Number 5, this was the geometric mean. If you remember the geometric mean in this particular problem, we're looking for the length of the altitude to the hypotenuse. And that gives us 3 similar right triangles, if you recall. And so we end up with a proportion so that we're going to use that value twice. So it's going to be x over 8 and 30 over x. All right, that was the geometric mean. You had to use your unknown value twice. And you always ended up with x squared equals, in this case, it's of course going to be 8 times 30, where x squared is 240, and I will have to find the square root of 240. Which is 15.5. 15.5. Again, I did the square root of 240 to solve that because it's x squared. Number 6. This is just a straightforward proportion. We know that whenever it says that it's the triangle is divided by a parallel segment, that it's proportional. So 4 over 12 is the same as x over 24. I know some of you guys could probably do this in your head without the proportion, but I'm going to work it out. I do get 12x, and that's going to be what, 96. Divide both sides by 12. And of course, the value of x is 8. Number 7, same thing. We have an angle bisector. We know angle bisectors split the triangle into proportional parts. So x is to 8.5 as 19.1 is to 4.1. Make sure you're looking at that correctly. So again, be multiplying and dividing on this one. Let's see, 8.5 times 19.1 is 162.35. And then you'll just divide both sides by 4.1. And rounded to the nearest tenth is going to be 39.6. 39.6. All right, number 8. This is a prism. All prisms have the volume formula of the area of the base times the height. Since this is a triangular prism, we have to use the area formula for a triangle. So if I'm looking specifically at, and I know it's a right triangle down here, a half times the base times the height of that triangle is the B. And then this H is actually the height of the prism, which happens to be 17. So the volume is going to end up just being 17 cubic meters after I multiply. Number 11 is a cone. The volume formula for a cone is 1/3 times pi times the radius. So that's going to be 9. Squared times the height of the cone, which is 26. It does tell me to round to the nearest tenth, so instead of pi, I'm going to use 3.14 in my calculator. So 3.14 times 9 squared times 26. All of that would be divisible by 3. And I get to the nearest tenth, 2,204.3 cubic meters. All right, number 12, I need to graph this. Let me actually add a page down here and do some graph paper. Okay, so I'm gonna, let's get rid of that. So it was number 12, is that right? Yes, okay. Oops. All right, so number 12, we're asked to classify the quadrilateral. So I am going to expect to see a graph and your work on number 12, because you can't just graph and go, oh, that looks like a whatever. You're going to need some proof here. We're in geometry class. Okay, so I'm just going to draw my axes really quickly. All right, so it says that point E is at negative 5 and 1. 1, 2, 3, 4, 5 and 1. There's E. F is at negative 1 and 1, 2, 3, 4, 5, 6. G is at 4 and 1, 4, 1. And H is at negative 1, negative 1, 2, 3, 4. H is down here. So the reason why we do like to graph it is because it at least gives us an idea of what it potentially could be. And so it's looking like this one potentially could be a kite. It's obviously not a rectangle or a square. It certainly doesn't look like a parallelogram or a trapezoid. So if I look at it sideways, it does look potentially like these two sides might be congruent and these two sides might be congruent. So what I've got to do is show that either they are or they are not. So I can classify it appropriately. So I'm going to have to use the distance formula on this one. Again, please refer to the PDF document if you want to see that formula in a nice, neat form. So I'm just going to go around and find the distance of all the sides. So the distance from E to F would be negative 5 minus negative 1 squared and 1 minus 6 squared. So that's going to be what? 16 plus 49. So that's going to be the square root of 65. Okay, so that's the distance on this side. And then if I do the distance from E to H, I want to see if it happens to be the same. So I'm using the points E and H. So negative 5 minus negative 1 squared. And 1 minus negative 4. 1 minus negative 4. 4 squared. Okay, so let me make sure I'm doing that right. Negative, and then 1 minus negative 4. Yeah, that's correct. Okay. So that gives me what? That's 16 again. And this time it's 25. So 16 plus 25 is what? 30, 41, square root of 41. Okay. So maybe not a kite. Double check my calculations. Negative 5 minus negative 1, that's correct. And 1 minus negative 4. Yeah, okay, I did that right. Okay. Well, let's just go ahead and check the other two sides and see what we come up with. So the distance from F to G is going to be the square root of. So this time I'm obviously using the points F and G. So negative 1 minus 4 squared plus 6 minus 1 squared. 6 minus 1 squared. Yeah. Okay, so what do I get? I get negative 1 minus 4, that's 5, so that's 25, plus 25, that's the square root of 50. I just really feel like I did a calculation wrong somewhere. I'm going to double check my work in just a second. This has turned out really funky. Alright, so now I need to do the distance from H to G. From H to G. Alright, that's negative 1 minus 4 squared plus negative 4 minus 1 squared. So this one's going to also end up being 25 plus 25. So see, that's the square root of 50 again. I want to go check. Maybe I did E to F incorrectly, so let's look at my E to F. So E is negative 5 minus negative 1. I did that correctly. And then 1 minus 6 is... Oh, see, there's my mistake. Okay, I knew it looked like a kite. 1 minus 6 is not 7. 1 minus 6 is 5, so that should be 25. And that's why we always write in pencil in Miss Wyndham's class. And so that indeed is the square root of 41. Okay. I knew that was throwing me off. Square root of 41. There we go. So it indeed is a kite. Kites are classified as quadrilaterals with 2 pair of adjacent congruent sides, not opposite congruent sides. So the answer to number 12 is that it's a kite. So you can't just graph it and go, hey, that looks like a kite. You have to do what I did and show that things are congruent or perpendicular. Number 12. That was kind of fun. Number 13, finding the equation of a circle. Again, that's on the other paper. It's really, just be careful with your signs, right? It's just going to be x plus 7 squared plus y plus 6 squared, because you're going to have minus a negative 7 and minus a negative 6. And don't forget, you have to square your radius, so 2 squared is 4. So 14 is just that backwards, right? So for the center on this one, whenever I pull those numbers out, it's going to be a positive 4 and a positive 8 because of that negative already built into the formula. And the radius is going to be the square root of 9, or 3. Number 15 is the same-ish as 13, but instead of giving you the radius, because they do give us the center, we know that's obviously going to be the H and K, but it tells me that, it also passes through this point. So if I found the distance from the center to that point, that would be the radius. So I'm going to do that real quick. I'm going to use the distance formula again. Should be well versed in it this time. Maybe I'll subtract correctly this time. 3 minus negative 4 squared plus 5 minus 10 squared. It's going to be 7. That's what, 49 plus 25. The square root of 49 plus 25 is going to be your radius. So what is that, 74? Yeah. No, I said 74 and I didn't write it. Okay, so this is the radius. There's no reason for me to find the decimal because just like how we found this 4 here, I had to square the radius to get 4. So I would have to square the square root of 74 to get the radius. So the answer to number 15, to write it down here, is going to be x minus 3 squared plus y minus 5 squared. And then when you square the square root of 74, you end up with just a 74. Yeah, okay. Number 16, these are our tangents moving into the circles. We know if that's tangent, that's a right angle, and that's a right angle. That's one of the properties we learned. That's 90, that's 90. It tells me the angle O is 138, and this is another kite, actually. And we know in a quadrilateral, the 4 angles add up to 360 degrees. So I just need to add everything up here. And with how my evening's going, I'm going to use my calculator just to make sure, because I am in a little bit of a hurry. And you've all met me before. So 318, so 360 minus 318, of course, is going to be 42 degrees. So that's the value of angle X. All right, number 9, the volume of a cylinder is, the volume is just, again, it's the area of the base times the height of the cylinder. The cylinder is on its side. The base is a circle. Here it does ask me to leave it in terms of pi. So pi times the radius squared times the height, which is 8. So really all I need to figure out is what is 3.8 squared times 8, which is 115.52 pi cubic meters. Number 10, the volume of a pyramid is 1/3 times the area of the base. In this case, the base happens to be a square, and we know to find the area of a square, it's just length times width, or side times side, and then times the height of the pyramid. So 11 times 11 times 15, and then 1/3 of that, is going to be 605 cubic centimeters for number 10. Okay, I must have scanned that in the wrong order, guys. I was going to say, wait a minute. So, yeah. I was kind of wondering why I went back to volume there. Miss Wyndham can count too, but just not late on a Sunday evening. Okay, so here we have another tangent going back to circles. Again, since it's tangent, we know that that's a right angle, which means that's a right triangle. It tells me that the distance from A to O is 24, which happens to be the radius of the circle. And then from B to C is 27. My job is to find the length from A to B. Now, I also know the length from C to O is 24 because it is also the radius of the circle. So that means the entire hypotenuse of that triangle is 51 whenever I add 27 and 24. So this is just the Pythagorean theorem. We know we couldn't have a test without getting away from the Pythagorean theorem. So AB is a leg. So A squared plus 24 squared, and then the hypotenuse squared. So what do I get? Let's see, 51 squared minus 24 squared. That's 2025. That's a nice number, right? Yeah. 45, right. So A squared. So A would be the square root of 2025. It is the Pythagorean theorem. We've only done that once or twice this year. Okay. Number 8. In circle O, angle R, which is right here, is 42 degrees. My job is to find angle O. Well, we know that angle R is an inscribed angle. And inscribed angles are always half the size of the intercepted arc. So that means this arc here is 84 degrees. Right, 42 times 2. It's always half its size. And we also know that the intercepted arc and the central angle, which happens to be the angle I'm looking for, are the same measure. So my answer is just 84 degrees. Number 19, I have two chords that are intersecting inside a circle, creating that angle. I'm actually looking for that angle. They tell me that AB is 20, and this picture is obviously not to scale. I'm so glad they say that. And that's 47. And if you remember, the rule is you find half of the sum of those two arcs. So I will be finding the half of 47 plus 20, or a half of 67, which would be 33 and a half. So that angle is 33 and a half. All right, the last one. I like these. I'm looking for the chord inside the circle. They tell me that this chord is 18 and the exterior portions are 10 and 5 respectively. The rule was, since the angle is on the exterior of the circle, is the outside portion times the entire segment. So I do have to add those together. And the same thing on the bottom, the outside portion times the entire segment. Right, 10 and 18, 5 and x. And then I got to work it out. It's a little bit of algebra. 5x plus 25 using the distributive property. And then 10 times 28, of course, is 280. Subtract 25 from both sides. So 5x is what? 62. 55. 280 minus 25 is 255, right? Yes, I knew that. And then divided that by 5, and I should get 51. So x is 51. All right, guys. That's your exam.